Good morning. This is Palanivel Rajan. I am working as assistant professor in the Department of Electronics and Communication Engineering. In today's session, I am going to handle microwaves, basics and necessity. So before entering into this topic, I want to recall you what do you mean by wired and wireless communication. So for a past decade, we are getting into wired and wireless communication. The thing is that, so the reason for migrating from wired to wireless communication is that we are going to achieve long range of communication. So for achieving this long range of communication, we want this microwaves. Okay, without microwaves, we can't able to achieve this long range of communication. So the reason for migrating from wired to wireless communication is that to achieve the longer range of communication. So now let me tell you what do you mean by microwaves. So microwaves in the sense it's a form of electromagnetic radiation, that is EM radiation, that is electromagnetic radiation. It is a form of electromagnetic radiation whose having the wavelength ranges from 1 meter to 10 millimeter. That is, it is also called 100 centimeter to 10 millimeter. So based on this, based on the wavelength of this microwaves, we can classify these microwaves into two types. One is millimeter waves and another one is centimeter waves. So next we are getting into the frequency range of microwaves. So what about the frequency range? The normal frequency range of microwaves is 300 megahertz to 300 gigahertz. So this is the exact frequency range of microwaves. So while we are talking about the frequency of microwaves, so let me tell you one small typical example. So in our institution we are having 2000 students. We can't able to accommodate all the 2000 students in a single classroom. So that we can classify the students into department wise and section wise. The same thing we are going to do here. So we can't able to use the same frequency from megahertz to gigahertz. So we are going to categorize this frequency range into so many bands, that is called frequency bands. So here I am going to discuss only the four frequency bands that we are going to use. First one is L, second one is S, third one is C and fourth one is X. This L band stands for 1 to 2 gigahertz of frequency, and the same thing this S band stands for 2 to 4 gigahertz of frequency, and the C band stands for 4 to 8 gigahertz of frequency, and the last one X band stands for 8 to 12 gigahertz of frequency. So I like this, so many frequency bands we are having. So among these frequency bands, one special band is there, that is called ISM band. So why I am insisting this ISM band in the sense, so this ISM stands for industrial, scientific and medical application. Okay. So normally spectrum allocation can be done with the help of licensed and unlicensed band. So spectrum can be allocated in two ways. One is licensed and unlicensed band. So I will tell you the example for licensed and unlicensed band. So licensed band in the sense, for commercially we are using mobile phones, right? So we are having the MMS, SMS and making calls. So for accessing the services, the service provider may charge something. For example, for sending an SMS or making a call, the service provider may charging something. But that is the best example for licensed spectrum allocation. This unlicensed band in the sense, we are accessing Wi-Fi connection and Bluetooth for using the internet connection, right? So that is the best example for this unlicensed spectrum. Okay. So spectrum in the sense frequency allocation. So the frequency allocation can be done in two different ways. One is licensed band and another one is unlicensed band. So licensed band in the sense we are going to charge something, service provider is going to charge something for accessing their services. So that is the licensed band. So unlicensed band in the sense we can able to access the wireless services at a free of cost. That is the meaning of unlicensed band. So SMS, MMS, making calls are called the examples of licensed band, license allocation, and unlicensed frequency allocation has this Wi-Fi connection and Bluetooth. These are the examples of unlicensed band. Why I am telling this is this, as I already told you that this ISM band, that is industrial, scientific and medical applications, this ISM band having the frequency range of 2.45 gigahertz. So this licensed spectrum allocation having this frequency band, that is ISM band consisting of 2.45 GHz. So at this frequency only we can able to access the Wi-Fi or Bluetooth, whatever be the case. So that is a special case in this frequency band. So that's why I have mentioned this ISM band. So ISM stands for industrial, scientific and medical applications. So we can able to access this ISM band at free of cost. So for accessing the services we couldn't able to, we should not get any permission from the service providers. So that is a special case in this ISM band. So then we are getting into this microwave communication. So as of now we have confirmed that what is microwave, what is the frequency range, what about the wavelength. Now we are getting into the microwave communication. Communication in the sense we can already know that it's a transfer of information or transfer of data from one terminal to another terminal. It may be from transmitter to receiver. That is, we are having communication in the sense we are having two terminals, that is the transmitter and the receiver, and in between this you may have channel. So this is about the basic communication components. So from this terminal, from this transmitter, we are going to access the data, and the data can be received by the receiver side. So this is the basic communication part. If we are getting into wireless communication, means there is no physical connection between these two terminals. There is no physical connection between these two terminals. That is called wireless communication. So for achieving this wireless communication, we are in need of this microwaves. So by using this microwaves only, we can able to connect this transmitter and the receiver in wireless mode. So that is a special case of microwave communication. The exact definition is that, so we are going to transfer the information or data by using this EM radiations. As I already told you, this microwaves is a form of EM radiation, whereas the frequency, the wavelength ranges from centimeter to 100 centimeter to millimeter. So that is the exact definition of microwaves. So by using this electromagnetic radiations, we are going to transfer the information, that is called microwave communication. So as of now we have studied what is microwaves and what about the microwave communication, and what is this microwave actually present in the electromagnetic spectrum. So we know that electromagnetic spectrum is there. So in electromagnetic spectrum, this microwave present in between infrared and the visible light. So in electromagnetic spectrum, this microwaves can present in between the infrared and the visible light. So this is about this microwaves. After that we are getting into this advantages and applications of microwaves. So let us discuss one by one. What few advantages of this microwaves is, it is used in point-to-point communication, and next one, it is having broader bandwidth, and it allows frequency reuse. So these are the few advantages of microwaves. For example, it allows the point-to-point communication, point-to-point telecommunication, and we can able to get the broader bandwidth, and it can able to allow us to use the frequency twice or thrice. We can able to achieve the high data rate, and the last one is antenna size is going to be used is very small. That means that, so already we know the relation between C and frequency, that is a lambda, wavelength and frequency. So here we are getting into this microwave for higher frequency components, higher frequency communication. That means that we are getting into this longer range of communication. Longer range of communication in the sense we are going to increase the frequency. So we are going to increase the frequency means automatically this wavelength gets down, because by using this relation we can conclude that this wavelength and the frequency are inversely proportional to each other. So whenever we are increasing the frequency, this wavelength is going to reduce. So the wavelength going to reduce means automatically size is also going to be reduced. So what are the components we are going to use for microwave communication? That size is going to reduce by using this type of relation. So this is a very important relation. So lambda, there is wavelength which is equal to C by F. This lambda stands for wavelength, and the C stands for velocity of light, and this F stands for frequency. So the relation is that this wavelength and frequency are inversely proportional to each other. So we are getting into this higher frequency communication. So while we are increasing the frequency, this lambda value gets dropped out. So while we are reducing the lambda value, that automatically size is also getting reduced. That is, whatever the antenna we are going to use for transmitter and receiver, both the size of the antenna is going to automatically miniaturized. So that is the best advantages of this microwaves, and we are getting into applications of microwaves. So first one is spacecraft application, and the second one is mobile communication, and the third one is satellite communication, and the fourth one is radar communication, and the last one is we are having for heating applications. We can use this microwaves for heating applications. So now these are the applications of microwaves. So after that we are going to map any one of this advantage with this applications. So now I will tell you. So we are talking about microwaves continuously. Then you may have one question, right? So how this microwave can able to generate? So already we are having 4 types of sources for generating the microwaves. I will tell you the sources of microwaves first. First one is magnetron. Second one is reflex klystron, and the third one is 2 cavity klystron, and the last one is helix traveling wave tube. So these are the major sources of microwaves. By using this type of devices, we can able to generate the microwaves. After that, amplification is also possible. So the amplification and the generation of microwaves is possible only by using these 4 types of sources. So after that, we are going to map this applications of this biomedical that is microwaves with this advantages of mobile communication. Okay, so just we are going to map the mobile communication application with the frequency reuse. So now I will tell you what is frequency reuse, and in mobile communication what are the terminologies we are going to discuss. So let me tell you, right? So frequency reuse in the sense we are going to use the same frequency in different cells, provided that there is enough distance between those 2 cells. That is called the frequency reuse. So before entering into this, we want to know what is cell. So the cell in the sense the entire geographical area can be split into uniform small areas, that is called cell. So especially in mobile communication, the entire geographical area can be able to divide it into small areas uniformly small areas, that is called cell. So for each and every cell we have some frequency. For example, let me tell you, if A, B, C, D cells are there, means automatically for A cell we are having F1, F2, F3 and F4 frequencies. So these are the cells available. So for each and every cell we are having the frequency range from F1, F2, F3 and F4. So that is the meaning of the word cell. So after that we are having this frequency reuse. The frequency reuse in the sense so here the A cell is having F1 frequency. Let us assume that this A cell is having F1 frequency, and meanwhile this A1 cell is also having F1 frequency. The same frequency can be used in 2 different cells. These 2 different cells are called co-channel cells. Okay, so the same frequency can be utilized in 2 different cells. Those 2 cells are called co-channel cells. So the same frequency, there's F1 can be utilized here A as well as A1. There should be some interference. The reason is that so the same frequency can be utilized in both the cells, for both the cells. That is, you may have one more question. Again, I have insisted that the shape of the cell is hexagonal shaped. So I am not at all preferring this triangle, I am not at all preferring this circle, I am not preferring any triangle or a square or whatever the case. But the reason is that if you are preferring a triangle, means the coverage area becomes reduced. Okay, if you are having a circle, means you may have like this. some portion may be uncovered. So this area is called black spot. This particular spot doesn't have any coverage. So that only we are not at all preferring this circle. And one more thing, if you are merging with each other means, if you are coincide with each other means, this ABC gels coincide means automatically this area having some interferences. So in order to avoid this interference as well as in order to increase the coverage, we are getting into this hexagonal shape. The reason for using hexagonal shape is that in order to enhance the coverage as well as in order to avoid the interferences. These are the two main reasons we are going for hexagonal shaped cell. Okay. So this is the meaning of this one. So after that the frequency reuse, we are having one channel assignment strategy. The channel assignment in the sense, so we are having transmitter, we are having receiver, in between we are having some channels. So we have to allocate the channel for the users. So the channel assignment can be broadly classified into two types. One is fixed channel assignment and another one is dynamic channel assignment. So channel in the sense it is a path or it is a way the signal can able to propagate from transmitter to receiver. So the channel assignment in the sense we have to allocate some channel or path or some way for the wave can able to propagate from transmitter to receiver or from receiver to transmitter. So this type of channel assignment can be classified into two types. Number one is fixed channel assignment and number two is dynamic channel assignment. So fixed channel assignment means let us assume that user A is permanently allocated with the channel C1. That is the meaning of the word fixed channel assignment. So user A is permanently allocated with the channel C1. Okay. So but here in dynamic channel assignment, based on the request from the users, we are going to allocate the channels. So that is a difference between these two type of channel assignment strategies. Fixed assignment means only one user can be allocated with the one channel permanently, but in the dynamic channel assignment, this based on the request from the user, we are going to allocate the channel. So that is the difference between these two strategies, and which one is better? Surely this dynamic channel assignment is to be better one when compared to fixed channel assignment. Let us consider one commercial example for this one. So let me tell you, one conference hall is there. Okay. So one conference hall is there. So this conference hall is exclusively for only one department. That is the example of this fixed channel assignment. Okay. The same example, same conference hall, it can be shared by department A and department B. It can be shared by department A and department B. So based on the request from the department, we are going to allocate the channel. So which one is better? We can consider this dynamic channel assignment is the better one, in the sense of we are going to allocate the resources effectively. We are going to use the resources effectively. That is the main reason between this fixed channel assignment, dynamic channel assignment. So far we have discussed what is microwaves and what is the need for microwaves. So after that we are getting into the frequency ranges. In frequency ranges we are having so many bands. Among these bands we are having ISM band, that is industrial, scientific, medical applications. The specialty in the ISM band is that we are going to use the band at free of cost, that is unlicensed spectrum is available in this band, and after that we are getting into this advantages and applications of microwaves, and we are going to map this mobile communication with the frequency reuse, and after that we are having what is the meaning of frequency reuse and what are the channel assignment strategies for this session. Okay. So thanks for the opportunity given to me. Thank you very much.